Section 2.2, Linear Equations in One Variable. The definition of a linear equation is any equation that can be written in the form ax plus b equals 0, where a and b are real numbers. So let's solve a few. The equation 2x plus 7 equals 19. First thing we'll need to do is undo the addition by subtracting 7 from both sides, which is 2x equals 12 is our new equation. Now, subtracting a constant from both sides or dividing by a constant other than 0 is something we can do that preserves our solution. So this isn't changing our equation any really. Okay, we're making it in a simpler form. So subtracting 7 gives us 2x equals 12, and then we can divide by 2 on both sides so that we have the simplest version of this equation, which is x equals 6. A very important fact about equations is that we can check our solutions. So let's take the equation 2x plus 7 equals 19. Our proposed solution is x equals 6 at this point. So we will replace x with 6 and evaluate that. And we hope this comes to be a true statement. So 2 times 6 is 12, plus 7 is in fact 19, so our solution is x equals 6. All right, for another equation, we have something a little more complicated. 4 parentheses x minus 3, close parentheses, plus 12 equals 15 minus 5 times the quantity x plus 6. So first, we will need to distribute a few things and then combine like terms. So if we distribute the 4 on the left-hand side, that's 4x minus 12 plus 12 equals 15. We'll distribute the 5 on this side. And because that is a subtraction sign, we're going to change this to 15 minus 5x minus 30. Now next we're going to combine like terms. So we have a single x term on either side, so let's not touch those. But we are going to combine the constants we have on both sides. On the left-hand side, this will be 4x, because negative 12 positive 12 is 0. On the right-hand side, we get negative 5x minus 15. And now, because we have x terms on both sides, we're going to add 5x. Now, you could subtract 4x. You could move the variable to whichever side. This is actually easier, though. So this is 9x equals negative 15, and then dividing by 9, we find that x equals, that would simplify by 3, so negative 5 thirds. To check this, I can say 4 times x minus 3, so that'd be negative 5 thirds minus 3 plus 12 equals 15 minus 5 times negative 5 thirds plus 6. I can check that. All right, and I'm going to use a calculator. I'm going to evaluate the left-hand side and evaluate the right-hand side, and they ought to be the same. It's 3 plus 12. The right-hand side is negative 20 thirds. And the right-hand side, make sure we work inside the parentheses, then multiply by 5. Plus 6 is negative 20 thirds. So that is indeed a true statement, and our solution is x equals negative 5 thirds. The next type of equation we're going to have is a rational equation. And these are things that have rational expressions in them. So this first equation we have is 7 over 2x minus 5 over 3x equals 22 thirds. Now what we're going to do is first observe that we cannot divide by 0. So we have to make sure that 2x is not equal to 0 and that 3x is not equal to 0. Both of those together says that x can't be 0. So that is what we're going to call a domain restriction. We cannot have a value of x. That is not a solution to this. If it comes up as a possible solution, it cannot be 0. So we would throw that solution out. So how we're going to work this is we're going to clear our fractions. Equals 22 over 3. To clear our fractions by multiplying by the least common multiple of all of our denominators. All right, so what I'm going to multiply by is 6x. So multiplying by 6x on this will give me 7 times 6x over 2x. Write this out every step I possibly can. Minus 5 times 6x over 3x equals 22 times 6x over 3. Now everything's going to reduce, and that is actually the point of doing this. The first term there is going to be 21. The x's become 1. All right, we get minus 10 equals 44x. Now that will be 11 equals 44x. And dividing by 44, we get 1/4 equals x. So let's check that. Well, first, we know that our answer cannot be 0. That 1/4 is not 0, so that's fine. We don't have to worry about the domain restriction there. But let's plug this in. This would be 7 over 2x minus 5 over 3 times x. 22/3. So that would be, multiplied by 2, that would be 14. That would be multiplying by 4/3 minus 20/3. And would that be 22/3? Okay, well that would be 42/3. So that is, in fact, 22/3. So x equals 1/4 is our solution. This next equation, we'll do a similar thing. We want to multiply through by 2x. And for the same reasons that we had earlier, x cannot be 0. So let's multiply through. Minus 3 over 2 equals 7 over 2x. We'll multiply through here by 2x. The least common multiple of all of our denominators. That would be 4x over x minus 6x over 2. I'm just going ahead and multiplying that in. 14x over 2x. So we have 4 minus 3x equals 7. All right, subtracting 4 from both sides, we get negative 3x equals 3, and x equals negative 1. As long as we're not 0, we're okay. So I will go ahead and evaluate this. Check that. 2 divided by negative 1 minus 3 halves equals 7 times 2 divided by 2 times negative 1. Negative 2 minus 3 over 2 equals negative 7 over 2. And that would be a true statement. So our solution is x equals negative 1. Another rational equation, same concept. Here we're going to multiply through by 4x. Just go ahead and write that in here. And again, x cannot be 0. So this would be 4x over x equals 4x over 10. Actually, 4x is not going to work there. That's not going to eliminate all of our fractions. I mean, it'll still make things nicer, but it won't eliminate our fractions. Let's actually use something bigger than 4 so that we can eliminate all the fractions. We need a multiple of x, so it has to have an x, a multiple of 4, and a multiple of 10. So actually, I believe 20 will do it. Let's use 20. All right, that'd be 20x over x equals 20x over 10 minus 60x over 4x. So that will simplify to 20 equals 2x minus 15. So adding 15 to both sides, we get 35 equals 2x, which means x equals 35 over 2. I'm going to plug that back into my equation. X is not 0, so we're just fine in that regard. So 1 over 35 over 2 equals 1/10 minus 3 divided by 4 times 35 over 2. So this would be 2/35. 1/10, and that would be 3/70. Well, let's see. This would be 7/70 minus 3/70, and doubling that would be 4/70. That is certainly true, and x is equal to 35 over 2. All right, number 6, solve the following rational equations and state the excluded values. Okay, so again, for the same reasons earlier, we know that x minus 6 can't be 0, so that means that x cannot be 6, and on the right-hand side, x cannot be 0. Okay, now, what we're going to multiply here has to be a multiple of x and x minus 6. So we're going to multiply by x times x minus 6. So this will be 3x times x minus 6 over x minus 6 equals 5x times x minus 6 over x. Two things simplify there. This will be 3x equals 5 times x minus 6. All right, now this is a linear equation. 5x minus 30. Subtracting 5x from both sides gets us the new equation, negative 2x equals negative 30, and x equals 15 by dividing by negative 2. Okay, well, as long as our solution is not 6 or 0, we're in good shape so far. Now let's make sure it checks into this equation. So this would be 15 minus 6. 3 divided by 15 minus 6 equals 5 divided by x. So that'll be 15, which would be 3/9 equals 1/3. Well, 3/9 and 5/15, they're both going to be the same. So this is definitely true. So our solution is x equals 15. Right, part B, the least common denominator here, least common multiple of our denominators, is going to have a 2 and an x minus 3. So this will be 2x times x minus 3 over x minus 3 equals 5 times 2, that'll be 10 x minus 3 over x minus 3 minus 2x minus 3 divided by 2. Once we simplify this, we have 2x equals 10 minus x minus 3. Oh, our domain restrictions. This is all true as long as x is not equal to 3. That's our domain restriction. Well, distributing that, we have minus x plus 3. All right, simplifying a few things here. We get a 3x, adding the x to the other side, and then we have equals 13. So x equals 13/3. Now, let's go back and check this. X is not 3. That's good. So we have 13/3 over 13/3 minus 3 equals 5 over 13/3 minus 3 minus 1/2. Okay, well, that would be 1/3 in the denominator. Dividing by 1/3 would be 13. All right, again, that would be 1/3, so that would be 15. Wait, hold on. Let's check that. Oh, actually, that'd be 9/3. Okay, so that would be 4/3. Dividing by 4/3, which would make all right, 13/4. Okay, that works out a little better. All right, we'll get 4/3 there, so that'll be 15/4 minus 2/4. That is certainly true. And x is equal to 13/3. Last one in this problem, we will multiply by a 2 and an x minus 2. Again, the least common denominator, least common multiple of our denominators. Oh, and x cannot equal 2 because we have an x minus 2 in the denominator. Remember, we cannot divide by 0. So this will be 2x times x minus 2 over x minus 2. Leave that in parentheses. Equals 5. Make that 10. X minus 2 over x minus 2. Keep wanting to put equal signs. Minus 2, x minus 2 over 2. Reducing that, 2x equals 10 minus x minus 2. This is a lot like that last one. 10 minus x plus 2. All right, moving the x, we get 3x equals 12 and x equals 4. As long as x is not 2, we're in good shape. Let's just evaluate that. That'd be 4 over 4 minus 2 equals 5 over 4 minus 2 minus 1/2. So that is going to be 2 equals 5/2 minus 1/2. That would be 4/2, so that is certainly 2. And x is equal to 4. Number 7, solve the rational equation after factoring the denominators. 2, x plus 2 over x plus 1 minus 1 over x minus 1 equals 2x over x squared minus 1, and then state the excluded values. Okay, so first, the numbers that will make our denominator 0, let's go ahead and take care of that, are going to be -1 for the first fraction. -1 would make this dividing by 0. A +1 would make this 0. And then this last one, positive and -1 actually would make this. So generally we want to do this. I should have done this earlier. X plus 1 equals 0, x minus 1 equals 0, and x squared minus 1 equals 0. Solving these equations gives us -1, +1, and then this, the solutions are actually positive and -1. So those are our excluded values. We cannot have any denominators equal to 0. Now let's see about simplifying here and clearing our fractions. I'm going to go ahead and factor this denominator. So that is x plus 1, x minus 1. It's a difference of squares. So my least common denominator is going to be x plus 1, x minus 1. Alright, so this is going to be 2x plus 1, x minus 1 over x plus 1 minus 1, x plus 1, x minus 1 over x minus 1 equals 2x, x plus 1, x minus 1 over x plus 1, x minus 1. So a few things will simplify. This will be 2 times x minus 1 minus 1 x plus 1 equals 2x. Distributing our 2 and our 1 there, we get 2x minus 2 minus x minus 1 equals 2x. Now combining all of our x terms together, these two can combine. I'm going to subtract 2x from this side. Will get us a -1x, and I'm going to add 2 and add 1 to the other side, so this will be equals 3, so that x equals -3. I know I'm sort of waving my hands through the solving there, but x is equal to -3. Now what we said it could not be was positive and -1. So -3 is just fine. I'm going to see if I can check this over to the side. 2 over, if I evaluate that at -3. Okay, minus 1 over -3 minus 1 equals 2 times negative 3 over negative 3 plus 1, negative 3 minus 1. So I get negative 1. I get positive 1/4. And that will be negative 6 over, we have a negative 2 there and a negative 4, so that would be positive 8. Okay, well, that would be 1/4 minus 1 is negative 3/4, and that is negative 3/4. So it is true, and our solution is x equals negative 3. Okay, we're going to transition just a bit into graphing linear equations. To begin with, we have slope. The slope of a line refers to the ratio of the vertical change in y over the horizontal change in x between any 2 points on a line. It indicates direction and steepness. Okay, it's how steep the line is the quantity, but the sign tells us whether it's going up, increasing to the right, or whether it's decreasing to the right. And another way you can write this is delta y over delta x, the change in y divided by the change in x. So let's apply that formula to find the slope here. I'm going to call these x1 and y1, x2, y2. So if I use that formula, this will be y2 minus y1, so that would be 3 minus negative 1, 3 minus negative 1, divided by negative 5 minus 2. And that would be positive 4 and a negative 7, so we have negative 4/7. That means that that slope of that line is decreasing. Okay, the line is decreasing going to the right, and 4/7. That's not very large, so it's actually a rather shallow slope. Example 9, identify the slope and y-intercept given an equation. So the equation that's being used here is y equals mx plus b, where this is our slope and this is our y-intercept. So when we get to graphing, we're going to see that. So in this case, our slope is negative 3/4, and our y-intercept is negative 4, or the point 0, negative 4, as we'll see when we graph that. Example 10, find the equation of the line with the slope m equals negative 3, passing through the point 4, negative 8, and write the final equation in slope-intercept form. We're going to have to use two equations here. The first is called point slope. Point slope form of a line. Well, it would help if you could read that. Point slope form of a line, which is y minus y1 equals m parentheses x minus x1. And we want to end in slope-intercept form, which is what I mentioned just a moment ago, y equals mx plus b. First we'll use the point slope, so y minus y1, so y minus negative 8, I'm going to go ahead and write that as plus 8 because I'm subtracting a negative there, equals m, that's negative 3, x minus x1, so x minus 4. So that is the equation in point slope. Now, if I want this in slope-intercept form, I need to distribute and isolate the y value. So if I distribute that negative 3, negative 3x plus 12 equals y plus 8, and then isolating the y, I get y equals negative 3x plus 4. Okay, moving on. Example 11, find the equation of the line passing through the points 3, 4, and 0, negative 3. Write the final equation in slope-intercept form. First, we'll find our slope. We'll find our slope using what we have used previously because our slope isn't given to us. Okay, so we need to figure out what that is. So x1, y1, x2, y2. This will be negative 3 minus 4 divided by 0 minus 3. That's negative 7 over negative 3, so our slope is 7/3. Our slope is 7/3. Now we can pick either of those points using our point-slope form and get it in the slope-intercept form. Alright, let's go ahead and go for the point-slope. I'm going to go ahead and use the first point. Y minus y1, so that would be y minus 4, equals m times x minus x1, which is 3, which makes y minus 4 equal to 7/3 x minus 7, and then adding 4 to both sides, y equals 7/3 x minus 3. Now I would like to point out that rather than doing all of this with the point slope, if we had noticed that our y-intercept is actually right here. Okay, our y-intercept is always in that form, so y equals mx plus b. Value at that point, that value b, can actually tell us if it's a point where the 0 is the x-coordinate, that'll tell us that's our y-intercept. If you notice, negative 2 or negative 3 there, and there is our negative 3 y-intercept. Alright, next example, find the equation of the line with m equals negative 6 as our slope, passing through the point 1/4 comma negative 2. And it says write it in standard form. Standard form means ax plus by equals c form. So we're going to do like we've done previously, but we will rearrange it just a bit at the end. So y minus y1, so that'll be plus 2. Y plus 2 equals negative 6 times x minus 1/4, which means y plus 2 equals negative 6x plus 3 over 2. And then subtracting 2 from both sides, we have in slope-intercept form negative 6x minus 1/2. Alright, now to get this in standard form, we're going to have to clear our fractions and then get our x and y terms on the same side, if you notice this right here. So this is specifically when a, b, and c are integers. So we have to make sure that they are all integers, meaning we clear our fractions. So let's clear this by multiplying by 2. So we have 2y equals negative 12x minus 1. Now adding 12x to both sides, 12x plus 2y equals negative 1. And there it is in standard form. Now another restriction that's very common is that the a term, the coefficient on the x term, is generally positive. So keep that in mind as you're working through some of these. Find the equation of the line passing through the given points. We've done this before. x1, y1, x2, y2. Our slope will be 4 minus negative 3 divided by 1 minus 1. That is going to be 7 divided by 0, which is undefined. So the slope is undefined, which actually means this line is not a function. Whenever we have an undefined slope, if you notice, we have the same x value on both of these. Because we have a shared x value, the equation is going to be x equals 1. So this line is represented by all points that have 1 as a first coordinate. Number 14, graph the equations of the given lines and state whether they are parallel, perpendicular, or neither. Okay, well, parallel means they have the same slope when it comes to linear functions. They have the same slope. Perpendicular means they have opposite reciprocals as slopes. The slopes are opposite reciprocals. And neither is every other case. So let's first isolate the y value and graph these two. Well, for this first one, we will divide by 3 on both sides, which gives us y equals negative 4/3 plus 1, 4/3 x plus 1. So to graph that, I'm going to start at my y-intercept of 1, and I'm going to go down 4 and to the right 3. Okay, which brings me to the point 3, negative 3. And I can go in the opposite direction, up 4 points, up 4 in the, so vertically 4, and horizontally 3 to my left. Okay. For my second equation, I'm going to first subtract 3x. Remember, I'm isolating my y value. So that gives me negative 4y equals negative 3x plus 8. And then dividing by negative 4. Y equals positive 3/4 x minus 2. So let me graph that in red. We'll start at our y-intercept of negative 2. We will increase our y value by 3 and then go to the right 4. Or decrease 3 and to go to the left 4. Oh, I missed that point. There they are. Now, these lines appear to be perpendicular. Perpendicular. Okay, now how we know this is if we look at our slopes. Our first slope is negative 4/3, and our second slope is 3/4. I said that they were going to be opposite reciprocals if they're perpendicular. Well, they are opposites because one is negative, one is positive. That's the opposite portion of that. Now, reciprocals, meaning these fractions are flipped, is the way most people would say that. Okay, we have 4/3, 3/4. Okay, so those two appear to be perpendicular, and it is because they are based on our slope values. Let's look at our next problem. Write the equation of the line parallel to this line, and it passes through that point. So what they have not given us in this question is our slope. However, because they're parallel, they are going to have the same slope. So let's find the slope of this equation. If we isolate our y value, we won't have to get it in slope-intercept form to tell. That would be 3y equals negative 5x plus 1, subtracting 5x from both sides. And then dividing by 3, we have y equals negative 5/3 x plus 1/3. All we care about here is that the slope is negative 5/3 because it is the parallel. It's parallel to that line. So the slope, our parallel slope, is going to be negative 5/3. They'll be the same. Now we'll take that slope paired with our point to find the equation of our line. So y minus y1, which would be 5, equals m times x times quantity x minus x1. So distributing that, we'll get negative 5/3 x plus 5, y minus 5, adding 5 to both sides. We get y equals negative 5/3 x plus 10. And I would suggest that you graph those two lines and see, are they indeed parallel? And we should find that they are. All right, our last question for this section. Find the equation of the line perpendicular to 5x minus 3y plus 4 equals 0 and passes through the point negative 4, 1. So to find the perpendicular slope, we still want to find the slope of that line. So 5x minus 3y plus 4 equals 0. Let's isolate the y values. This will be negative 3y equals, we'll subtract those from both sides. Negative 3y equals negative 5x minus 4, dividing by negative 3. Our slope is 5/3 x plus 4/3. There's the equation of our line. So our slope here is 5/3, which means that the perpendicular slope is the opposite reciprocal. So for it to be the reciprocal, it becomes 3/5. To be the opposite, it needs to be a negative 3/5. So we're going to use that along with our point negative 4, 1 to find the equation of our line. Y minus y1, so y minus 1 equals slope negative 3/5 times x plus 4, because we're subtracting a negative 4 there. Distributing that, negative 3/5 x minus 12/5, that's y minus 1. Adding 1 to both sides, we get the equation y equals negative 3/5 x. All right, that will be a 5/5. This will be negative 7/5. And that is the equation of the line that is perpendicular. There we go. Perpendicular to that given line. All right, that brings us to the end of this section on linear equations.